end up at the number much quicker. So instead of doing 10 comparisons, you do 3 or something like that, and we'll work through that today. So what you're going to do is basically decrease the complexity from what we call ON, or linear, to a logarithmic complexity, which is basically the more it's all about the curve. And I can maybe pull up, I had a slide for that, but it's basically linear versus algorithmic curve. So maybe I can pull up a example. So yeah, something like that that I can share. See if I can share this. So you will be able to see that the actual curve is here. So if you see this, don't look at the other images, but basically the linear curve would look like this, right? It's basically a straight line. So you have your the time and basically the let's say the number of the size of the problem. In our case, it's the number of elements. So a linear would go kind of similar to the straight line, although it'd probably go more around the center. So you have the more elements you add, the more time you're gonna spend. So it really grows linearly, like this here, linear growth, right? This guy is this is kind of pure linear growth, right? So that's the more you get, the more you the more time it takes. Now in logarithmic, it's more of this. So basically, as you can see, the more time the more elements you get, the time is really not growing exponentially like linearly, right? It's flattening here. So you go farther into the number, the size of the problem, the actual time. If we use y-axis as the time that takes, as you can see, it's flattening, because you basically, and it's gonna really save you time, because you're not for each element you add to the size of the problem, you're not really introducing more and more time in a problem. So it kind of slows down, because we're not really going through each element here. So just to give you kind of a visual representation of kind of how why we're even doing this stuff. So very, very big time saver. All right, so before, like I said, any questions on this? That mostly what we discussed last time, but while I'm pulling up the slides for recursion, any questions on that's binary search? So binary search, and let's look at the recursion now. The recursion and binary search, like I said, go hand in hand. So recursion is really a function that calls itself. That's all it does. It's very, very simple. So as you saw in binary search, sometimes there is a need to kind of do the same thing. So when you do the same thing, you can use a loop, right, or something like that. But what's elegant is to kind of have a function and really outline. Recursion has a couple of things there. So you have the function, you have the parameters. So you have the exit condition, what's called exit condition, because when you use the recursion, you basically have in this, if you look at this simple example, so you have kind of the driver class main, and you have a function that takes no parameters. It's just called p, right? So and that function would just call itself and say hello, and then we'll call it, call itself again, right? So function that calls itself is a recursive function. So it does something and then does it again based on something else, right? So in this case, as you can see, what's going to happen? You guys guess what's going to happen in this little program. What if you were to run this? Any idea?
Is it gonna run it infinitely?
Yeah.
Or Stack Overflow.
Yeah. Whoever is adventurous, feel free to run this. You can crash your Java. It'll probably slow down your computer for a bit. You'll run out threads, and your other programs will probably be starved for threads and be slow. So your operating system will basically allocate all the random access memory. We talked about RAM, right? To this, basically, you're gonna have the stack, where your program or executes, allocate all the memory in your RAM that's available, and you're gonna gonna have to go into your processors and or kill the Java execution to stop it from taking all the space. So not cool, right? Useless, but you're gonna get a lot of hellos until you crash your computer. Now, that's where I talked about exit condition, right? So here is a little bit of a modification to this program. We still have that P for recursion, but now we've introduced something, and we are doing some type of counter here, right? And there is a condition that's called, like I said, an exit condition. Exit condition is what it means, basically what it says. When do I exit, right? How do I not do something forever? You don't usually want to do something forever. But exit condition is what kind of takes care of that. And here we are using a counter on a kind of a global level, and a class level variable, and that counter is what being used in this exit condition. We say when the counter equals less than equals to 5, we're gonna stop. So that's what we're gonna continue unless it's less than or equal to 5. So we're gonna do this 5 times, right? Or 0 through 5, 6 times. And then we're gonna stop. So this thing is only gonna execute 0, 1, 2, 3, 4, 5 times, right? So that's really a more of a realistic example. We have an exit condition here. So you're gonna call a child, the function gonna call itself, but at some point it's gonna stop. So the exit conditions usually depend on different things, right? So you could use some type of class level variable. That function always has the visibility into class level variable, and or you could use a argument. So an argument is something that you pass to the function as well. So you can pass arguments, and that's where you're gonna basically spend time today. You're gonna pass argument to the function, and you can base your exit condition off of the arguments rather than some type of a class level variable. Yeah, so far pretty straightforward, hopefully, right? So here is where we have something like an argument. So factorial, you guys know what factorials are? from your math classes. So factorial of a number is what? So
it's like multiplied by number minus 1 till 0.
Yeah, till 1, right?
Oh, sorry.
So yeah, exactly. So you know, you basically it's factorial. So you know, like if you Google it, example factorial, right? So factorial is so factorial of 5, right, would be 5 times 4 plus 3 plus times 1. So basically the you know, the number all the way to 1, right? So you know, obviously you don't want to multiply by a 0 because you will zero everything, you know, but you know, that's a number times number minus 1, number minus 2, number minus 3, and so on, right? So that's just a product of the number, you know, times the reduction of the number all the way to 1. So as you can see, you know, this one is also a very, very you know, a problem that fits our thing, right? All you're doing is really multiplication here, but you're just changing the parameters. So factorial of a number, right? So you just take a number, but first we know we actually going for that exit condition here, and we say if number equals 1, then we don't need to do anything, right? So basically a factorial of 1 is 1, and we just return it, because if we're past 1, you know, we are you know, we are done. We just return 1. If not, then we just say we do the formula, right? All you have to do is basically paste what, you know, what you see, you know, in the formula, whatever that our algorithm, right? So we say it's a factorial of the number. So all we need to do is we do the number times factorial of number minus 1. So all you need to do is basically take the number and minus 1. Right, so you know, we can kind of work through this and you know, basically see what happens here. So if we do let's say factorial of, kind of see how this works, right? So factorial of 5. So you know, we do the factorial of 5 is factorial of 5. Okay, so what happens here? 5 gets in. Is 5 1? No, it's not. So we do the factorial of 5 times the factorial of you know, of basically 5 minus 1, right? So 4. Okay. So then, as you can see, it's a little different, right? Here, you basically you call in a function. And as you can see, what's gonna happen is, as that function called itself, so you're saying, okay, give me return 5 times factorial of 4. So as you can see, nothing has been executed here yet, right? Nothing has been returned. So it's like that stack is being built. So I know it could be a little tricky to envision because it's different than what you guys are used to, but that stack is being built. Now, you know, basically we're not executing anything. As you can see, all the function is just returning another function calling itself, right? So factorial of 4 comes here, and then you basically you know, kind of saying, okay, is 4 equals 1? No. Then you know, you basically you know, you say times you know, factorial of 3, right, and minus 1. So so you kind of going all the way to 2, and then you get to the times factorial of 1, and that's where you kind of start actually executing, because that's where, you know, the execution starts happening. So, you know, when one comes here, you know, you basically start hitting that exit condition, and you know, that's where you basically going to you know, start executing the, you know, 5 times 4 times 3 times 2 times 1. So that's going to be your 100 and you know, 20 in this example. So so that's really you know, the gist of it. It's nothing but repeating the same thing, is just with the you know, with the exit condition. So any question on this? Does this seem straightforward, or you can again use this in very, very different you know, cases for your business logic. So anything that has kind of a repeating logic, if it's the, you know, this type of a program, right? A recursion function call in itself. The main thing about the recursion is you have the actual algorithm, and then you have your you know, you have your exit strategy. So when do you exit? When do you stop executing something? So those are kind of you know, the big things here to factor in. All right, so if no questions on this, let's go through our example that we wanted to do. And then let's just kind of talk through this. Remember, we kind of wanted to do the pseudocode brute force stuff. So let me bring up the Slack and the homework real quick here in a second. And let me start just kind of driving, and now you guys can pick it up unless anybody, you know, wants to just run with it. So 1 second, let me bring the problem back into our view here, which was where's it? Okay, so back here. Okay, so all right, so there's the binary search, right? So 1 second, let me just rearrange the screen a bit. Okay, so what do we have here, right? So we have an array, right? And then we have a target number, right? So we want to start going through. Let's you know, maybe give ourselves an array. So please give me, you know, input feedback how, you know. So let's give an array. Simple, right? 6, 7, 8, 9, 10. Just for, so we don't confuse ourselves, kind of just an array of you know, 10 elements here, 1 through 10. Pretty straightforward, but it doesn't really matter. Let's look for, let's say, number, you know, 3 here, right? So, or, you know, maybe to number 2. So we have a little bit more search. So so there's our array, there's our target number. Okay, and then we kind of start doing some thinking around this, right? So first, what do we need to do to start, doing here? So what do we need to start figuring out? What's our first step?
Split it into two.
Right.
Middle.
So int, what do we call it? Middle, right? Something like that. Equals array dot length. So right. Okay. So here will be 5, right? So 10 divided by 2 so far equals 5, right? So we did that, right? And then when we say, okay, well, what's our element at the middle, right? And then we say, okay, middle element equals array middle, right? Something like that. So then in this case, first iteration, so 0, 1, 2, 3, 4, 5. So will be 6, right? If we got 10 elements in an array, we divided array length time divided by 2, got to 5, and then since we're 0 based, we're going to the 6th element. 0, 1, 2, 3, 4, 5. I'm sorry, the 5th element, which is 6. So far, so good. Am I on the right track? No? So then, if we, so that's basically, we did this, divide the length of array, look at the middle element, and then we basically go and say, okay, element equals to target. So if middle element equals target number. So this is our exit condition, right? Return. What do we want to return? The, we found it, right? Return, whatever, the program calls for, you can return like true, or we can return maybe, I don't know, like index or something of element, maybe like middle element itself, whatever, we need it. So it doesn't really matter for this example, right? So that's kind of that's what we talked about when we said index. I'm sorry, the exit scenario, right? So somewhere we're going to stop. That's going to be our thing. But else, we said we got to do two things here. So we got two ifs. If that, so less, what do we do? So if it's less, what happens if middle element is less than the target number? What do you guys want to do here?
If the target number is less than the middle, we take a new array from the beginning to the middle number.
What do we do? How do we, what do you mean by take? Expand on that. You're on the right path. What do you want to do with it? What do you want to do here exactly? This is where our recursion will come in. Okay. So what do you guys want to do? How do you want to, so you already have a function, right? Hopefully like as you can, and it should be less, not equals. as you can see, you don't want to like do another, like, you don't want to, it's hard to use, not to use recursion here, right? It's like, then you have to what, slice an array again, right? So you have to like slice array from 0 to middle and like paste all of the above code or something like that, or create another function, right? Something like that. I mean, I don't see a clean way of doing that. Like you have to, you get the subarray and you kind of have to go through this again, right? Maybe in like a while loop or something like that. So it's a lot more. So, but you know, the problem, you know, hopefully you can see that we already did all of this, right? That's the whole beauty of the, you know, the recursion. You already have stuff that just takes an array and you know, and it basically it does stuff to it, right? So here's, so how would we actually call this? How would we call it ourselves? What would it pass? What are the arguments you'd pass here?
Erase the search, the element, and then the first index and the middle index -1. Is that what you mean?
Yeah. Okay. So say that again. So what are the arguments we would need to pass here? So we need to pass that array, right? So, but do we want to pass that same input array?
Just a half?
How do we get that? How do you think we can get that half of the array?
To split the length by 2.
I'm sorry?
To split it.
Split it. Is there like a Java function we can just split an array?
No.
I don't know, I'm just asking. So maybe if there is, that would be much easier. So would be probably cool to pass an array, right? So still the same array. And then the target number, right? We still need the target number. So this wouldn't work because again, we would do the same thing again. It would never, we're never shrinking the array. So how about we do something like that? Would it help if we just did an array and then we would tell it, okay, I want you to start from, take the array, so the same array, we're not splitting it because I don't know of an easy way to just like slice an array. I think there are some methods we can probably mess with, but if we just say, what if we just take pass 2 indexes here, right? So we would say, if we gotta go to the left, we say search this array from 0, right? So index 0, the leftmost, and so middle, right? We said we wanted to kind of -1, right? So this would basically cover the left side because we said now the middle is 6, right? And the number, the middle is 5, and that element is 6. So now we're saying our number 2 is less. So now we have to go through here and we're saying, okay, give us the 0 and the next all the way up to 5 minus 1 equals 4, which was going to be 0, 1, 2, 3, 4, right? So that would cover our left side. So we just say 0, middle, -1, Or if we are over, then what do we do here? So here we would need to do, not the 0, we don't want to go all the way to the left. What would we do here?
From middle to the end.
Yeah. How do we do the end? What do you guys?
Length minus 1.
I'm sorry?
Length minus 1.
So all the way to element at 9, 10.
So you offer to put 4 arguments in as a parameter?
Yeah. So here's where, right? So you're right. We need to, our initial problem, we basically, the way we started creating, we took an array, we took the target number. So now, as you can see, we need to, if we're going to do this way, we need to change our function here. So we can't just take the target number. We need to have an array, our indexes, and our
starting point and ending point, something like
yeah,
this.
yeah. So int start, int end, right? Again, unless we, and you can certainly, if there is an easy way to do the slicing here, you could have done the slicing, right? If there is an easy way, and you guys, when you kind of start implementing this next, just to kind of get it working and play with it, see if there is a better way. Maybe there's a Java like slice method. I know in JavaScript, there is a slice method for arrays. Basically, you will just, slice an array and return the subarray. I don't know if Java has anything similar to that. But again, I don't know Java as much as like I know JavaScript, for example. So if there is a slice method, good. But basically, this is probably the second best thing, unless you guys figure something else. But unless you go into, write another function and extract the subarray, this is probably the second best thing if you can't, cut off a subarray like we using a slice. So here now we need to obviously use the in start and in end, right? We are not really doing that here. So how do we change, this code? What do you guys think? How would this middle change based on, because we don't really have we don't really need to use array.length anymore. So we need to start looking at these guys. These are our guides post on what, we have an array that's never going to change, a million elements, but we are controlling start and end. So how do we calculate the middle based on that?
Start plus end over 2.
Yeah. Yep, easy, right? So now we've got that done. So now what happens? Any other things we need to change? All good? Is the rest look okay? All right, well, I guess we'll figure out, right? So seems like, we're doing the middle. We are, taking an array, splitting it by the middle. We're comparing the middle element to our target. That's not changing. And if we found it, then we're going to return whatever. Maybe we want to return the target number here, or index of the target number, whatever. If not, we basically continuing doing that same thing, right? So we're basically taking the left side, and that expression will not change. Left side will always be using the 0 as a starting index and kind of slicing the middle, you know, taking it one lower, and then the right side is going to be the most element is obviously going to be the length of a -1, except here the length we need to do something, right? So how do we, you know, well, you know, I'll let you guys do this because the length you'll need to obviously figure out. So it's the actual length of the array. So any questions on this? Does that make sense as far as kind of how we use recursion and solve this? Will you be able to put that in the code and give it a test?
Igor, what type of complexity did you say this one is?
This is a like a logarithmic O log of n complexity. So it's basically the let's see, O log of n. I'll try to show you. There's an image. So this is it, basically O log of n, right? So remember we talked, you see this where I'm pointing on this graph?
Yeah.
Yeah, so O log of n, this is basically the complexity here, versus O of n, which is linear, right? Linear, as you can see, size of input and the time it takes, right? As we have more data in our array, the time, you know, is gonna basically proportion. So we have, let's say this is 50 elements, the time is gonna be, let's say 5 seconds. This is 100 elements, the time is gonna be, let's say, you know, 10 seconds or something like that. So the more we do, the time is going to increase pretty proportionately. That's ON, that's kind of, you know, linear, which is really one-to-one relationship. Here, O log of n, that's what we're talking about here. You're going to, the more elements you get, the time is going to increase, but, you know, it's going to kind of start just, you know, being, it's not going to increase as much. It's still going to increase, but as you can see, you know, the more data you get, because you're doing these slices, right? As you can tell, we're, you know, instead of comparing 10 elements, we're going to compare like 2 or 3. If we add another element, 11, 12, 13, we're still going to compare, maybe, you know, we get another 10 elements, where the number of comparisons is probably going to grow by 1, not by 10. So that's why this curve grows much slower. It still grows, right? You're still going to get a little bit more time, just because you still got to continue adding, you know, the middle cuts and stuff like that, but it's not going to be, you know, it's not going to be as steep as the ON.
Is it correct that n here is the number of elements in the array?
Yeah.
Uh-huh.
So as you can see, remember we talked about the instant, right? So no matter how much input you get, the time always stays the same. So that's really O1 instant. Instant means, like, if you remember, accessing the first element of an array, or last element of an array, you just know the index, and it doesn't matter if array has 1 trillion elements or 5, still the same time. As you can see, you know, we talked also about ON squared. I mentioned that when we talk about loops, ON squared means the more data you add, the time is going to be really going up like crazy, right? So as you can see, it goes much faster than ON, right? It's just kind of keeps spiking much faster the more data you get. So that's when you write double loops, for example, you kind of going through elements twice, and that's why you have time complexity increase. And say, other ones, ON cubed and ON, they're even steeper, but we're not going to touch on those. The ones that you need to be aware is O1 or O log of n and ON squared. So kind of covers the other ones. Does that make sense? So, feel free to, look it up more, but really it's all about just kind of making sure your algorithms are, efficient. So, all right, so let's implement this, right? Get you guys some coding time. This is very close. Just spend a few minutes and knock this out. Let's see what works. Maybe how about this? Let's see, log how many. So to make it a little bit more interesting, so we can kind of see the impact of this. If you could, let's say, make an element, let's say of 100 integers, right? Just hardcore array of 100 integers. And when you are just doing these binary searches, so maybe you can do something console.log the number, right? So maybe here, the type of stuff, obviously not that, but maybe have some kind of a driver, the main program, and do a counter equals 0. And then here, maybe in the console, just keep so that you can kind of see how your program makes the problem solve faster, right? So this one, you would basically see how many times you actually call this binary, which binary does this, that actual comparison, right? When you're doing this comparison, so you can actually do it right here, right? Or kind of like this. Sorry, I meant to actually leave it. So this is probably makes more sense. So basically, every time you run this function, do add the counter, and then at the end, maybe just do the console.write or whatever counter, so we can see how many things how many of these you've done, right? So if you have an element array of 100, we will be able to compare, and you give it like 70 or 90 or something like that. We will have to compare how many of these things were done, comparing to like the worst case scenario. We did the linear search, which go through 100 elements or 70 elements, depending on the target number. So you can see the savings you generated by this function. Does it make sense? Cool. So what do you guys need to kind of productionalize this code and do the a little counter? How much time? $15 minutes could be okay. Oops, I didn't want to put it into the Zoom link. Well, so there's the pseudocode.
You could by writing console that write, you mean just to print?
Yeah.
Ah.
System.out, system, whatever.
So we need to count how many steps we need in order
Yeah,
to
how many
find
times you
our
call this
target.
binary search, basically.
Mm.
So every time your binary search gets called, you're doing this calculation, right? You're comparing this stuff. So just keep count on how many times the binary search gets called in this recursion. Okay. So spend 15 minutes, see, if we can get this. So, write a main function that will call this binary search, obviously, with, the initial arguments. So you're going to have to give it an array and initial arguments, right? So, the initial arguments are going to be probably the 0 to array length -1, right? You want to give initially the full array. And then, clean up this code at the console, and you should be done. Hopefully, when you find it, return. Yeah, you can actually, do the return. I don't know how do you want to. I guess end it so that we can see. We just, I guess we finish, and then the counter count is going to be how many times the binary search was called. So. Cool. All right, so spend 15 minutes and we can look at it in a few. All right. All right, guys, how's it going? Anybody was able to get it done? Working hard or hardly working?
Hardly working. It didn't work for me.
It did not?
Mm-mm.
Why not?
Neither for me.
Uh-oh.
First of all, I switched the right side and left side thing
Uh-huh.
because I think it was just a typo.
Uh-huh.
But yeah, it doesn't give me the right indexes.
Ooh. That sucks. Have you been able to debug to see what's going on?
It was showing like, yeah, I don't want to take anybody's time. Probably somebody solved it, so maybe they can share the screen. So yeah, mine just didn't work.
Well, I don't know. Did anybody? Doesn't sound like. So maybe Gia, unless anybody wants to share a working example, maybe you can share what's not working. Yeah, take a look.
I think I got it working, but I'm not sure that it's working correctly. I can share and show.
Yeah. Yeah, 1 second. Okay, go ahead.
Okay. Yes, okay, so it looks like it found it on the right side, but it didn't use the counter, so I probably should just delete it. The counter didn't work. Okay, so I just if my target is bigger than the middle element, then I just added 1 to the middle element. So I kind of created that recursion so it adds up. And if target is less than the middle element, I subtracted 1 from the middle element to kind of go back on the array. So yes, it found it on the right side, I think.
What
Yeah.
about, okay, cool. All right, so you got the exit condition, all right.
I don't know, maybe I should use some different, I didn't print something different.
It's fine, as long as we get something.
See my array, I use this array. It
Okay,
was 6, 7, target was 6, and
okay.
start was 0, and the end was length -1.
Mhm.
So we went 1, the middle was 4, and it went 2 times to the right. Looks like it found 6. Yeah, looks like it's working. Let's put some different number, maybe like 2.
Okay.
What is the index? I'm sorry, Katja.
Ah,
What is the index?
no, left side doesn't work.
There's that overstack, right?
Yeah, I don't know. Yes, this one start. It's supposed to be index, right? Or is it supposed to be a number? I think it's.
Oh,
It should be an index.
It's index. No. I meant what, like, does it find you an index of a number?
I don't know. It doesn't find anything. It just makes steps to the right or to the left. I didn't put any condition here, so probably we should do that. I just didn't have enough time for that. I was just trying to figure out how this thing works.
So one thing that's definitely missing is we need to have an exit condition, right? So I think you're and you basically saying print line middle on the exit. Okay, I see what you're doing. So then you're not crawling the recursion again. So the left side doesn't work, right? Which is the left side is that first else.
2, 0, and this is the index.
Should work.
Start ending, yes, because if I, for example, let's put 7.
Maybe there's a typo in your.
I mean, if it's 7, right side works. You see, it went 3 times. It made 3 steps to the
Right.
right.
Maybe there's some kind of a typo in your
Yeah.
L. Yeah.
Okay, now we just have to figure out how to make it beautiful.
Mhm. So that's where it's not working, right? The left side.
Left side, yes, the last one. So we started array.
So left side should be at the 0, right? So you should always go to the 0 as the first element. So I think that's where your problem. If you replace that with a 0 and give
Oh,
it,
here, should I put this start here? Like 0,
no, just the 0.
0. Let's try it with 0. I don't know. Let's see. Oh yeah. Oh no, I didn't. I didn't change the elements.
I'm not sure, but I don't think it should be 0.
Maybe not 0.
I think start was good
Start would be good. Let's see, and then we
because sometimes we do not start from 0, right? Sometimes we start from like second, or like the first half, but like, okay, I can't explain myself, sorry.
It's hard to explain. I know. Oh no, you see, it goes to the left, but it goes. I don't know from where. From 3. Why does it go from 3? Like left, 2 steps it keeps. Because when it goes to the right, it starts from 4 and it makes steps from the 4. But when it goes to the left, it starts from 3.
Right. It should go from the 1 to 3, and
Let's
the
put
1 is all. The first element is always at the 0, right? So that's.
Can you debug yours?
let's do it. Ah. Okay, let's see. Okay, so we start from 0, finish at 7. Looks like fine. Then this is our array. Target number is 1. Okay. Middle element is 3. Index 3.
This is second iteration, right?
1, 2, 3. That's the first iteration, I think.
Oh, is this first iteration?
It was
Okay.
entered and it found the middle index. I should change the name for the middle index. And then it goes here. Didn't find it here, so it went down here. Middle element, so 3. And let's go to the. I didn't find it here. Okay, so it's gonna look on the left side. It's gonna go inside, and it's gonna see. It goes up again. So now our end is 2. Why is that so? Oh, okay. He subtracted 1 from this. So our middle index was 3, and it subtracted 1. So now our middle index is 2.
Yeah.
And it goes down again, comes back here. Now our middle element is 1 because we subtracted 1 from 2. Now go back here, and now our index is 0. And it finishes. So yeah, basically it was, he executed this step like 3 times, 3 minus 1, 2 minus 1, and then 1 minus 1, until he found this first index 1.
Yeah.
Okay, it looks like it works.
It's good to me.
I think it works, right?
Yeah, yeah, looks like it's. Let's check some other number. I don't know. Let's do some. Let's find some. I don't know. 8. yeah, it finds 8. So it starts from the, what, I don't know, 4, 8, starts from 4 and makes, right,
We'll start at 5, 0, 1, 2.
yeah, it makes 4 steps to the right from 4. And if we, for example, pick 2, it's going to start from the index 4,
Yeah.
Why it goes only 1 step to the left? 2, 3, 3, index 3.
You should still start at 5, right? Because your array is 8 elements, right? 8 divided by 2 is 4. So you're always going to start 0, 1, 2, 3, 4 at the 5.
Should be 7, right? Index 7, no?
The last index is 7. So it's gonna take. Oh, maybe that's the
Maybe
problem.
not my 1.
Yeah, maybe I don't need this. It's that's the same thing. So the length is 8. Let's debug it. Okay, so end is 8 and start is 0. No, it's not right, right? We should put the start 1 if we use 8, right? If we do not subtract, if we do not subtract 1 here, we should use start as 1.
Well, yeah, you should probably do the length minus 1, like you did.
Yeah. Okay, so we start here, then we go. So it was 7 plus 0 divided by 2. And so middle index is 3. So middle index is 3. It's 1, 2, 3. Starts with 4. Okay. And it comes down here. It's not going to find it here. Okay, it comes down here. Target number is 2 and middle index is 3. So he does 3 minus 1. It will be index 2 now. So here we have our and is 2, is index 2. It means that 0, 1, 2. So this is our end index now. So, oh, you see it divides it by 2 and it becomes 1. So middle index is 1. Yes, and he finds it. So it's our new middle, because you see when he divides by 2, our new middle index is 1, and it checks if our array at index 1 equals to target, it returns me middle. Yeah, so he finds that because our new middle becomes this number. Man, that's interesting. It's so hard.
Yeah, well, spend a little time playing with that, right? So, goes for all of you guys. Just make sure you debug it, get different arrays in there, different target numbers, and kind of look, clean it up so that we can review it next time. Might be some bugs and stuff. Just tweak it how it should be, but hopefully you get the idea, right? How it should work.
Yeah.
Yes, sure. I'll try to make some sense out of it.
I have problem with the returns. I don't know, for some reason it doesn't stop.
Yeah.
At the return statement, it keeps going.
Yeah, well, it might be that, you know, either your exit condition is never met, or you know, something else usually, yeah. Or maybe you don't have like proper parentheses, but check that out as well. So, well, let's review this on Tuesday. So please try to finish this. You know, looks like you guys are very close, and hopefully this is helpful, and now you know what recursion is. All right. So always let me know any questions if you get completely stuck, but I trust that you'll able to solve the small bugs you may have, and with a little bit more time, get it to work 100%. So with that, good luck with your next class, and have a good weekend. I'll see you guys on Tuesday. Bye-bye.
Thank you.
Yeah.
Mhm.